Hi all, I'm Raghav and this is my data structures Fundamentals-1, Self-Found-1, Assignment-1, and today I'm going to discuss about the following three questions. What is the significance of time and space complexity? What is the data structure? And third is linear and non-linear data structures. So coming to the first question, what is the significance of space and time complexity? So every problem have multiple solutions and each problem requires a different space and time to get the desired solution. So, time and space complexity are the fundamental concepts in computer science that help us to analyze and understand the performance of an algorithm. So, time complexity measures the amount of time an algorithm takes to complete the function of an input size. It gives us an idea of how the runtime of an algorithm grows as input size increases. So, time complexity is usually expressed using big O notation, which provides us a worst case complexity of an algorithm. Now coming to the space complexity refers to the amount of the memory space an algorithm requires to run as a function of an input size. So it helps us to understand how the memory usage of an algorithm grows with larger input sizes. So it is also denoted by big O notation. So we can take an example. So suppose we are developing a 2D platformer game which have multiple game objects like enemies, obstacles, collectibles that needs to be drawn on the screen. So we want that each object and appearance are to be processed by a rendering engine. So let's say we have n game objects in the scene. So the rendering engine would be iterate through each of them individually, and it would give us a time complexity of big O of n. So uh, coming to the space complexity example, so let's say in 2D platformer game itself, we have a level with different layers, okay, such as background layer of platforms, a foreground layer of decorations on the platform. So each layer is essentially an array of objects or tiles that are need to be rendered. So the number of layers are denoted by L and number of tiles are denoted in the each layer is denoted by M. So if you want to keep all the layers in memory simultaneously, okay, so the space complexity would be big O of L into M. Okay, so next is what is a data structure? So data structure is a way of organizing and storing the data in computer so that it can be accessed and manipulated efficiently. So data structure provides a means to represent and manage data in structural and organized manner, enabling the various operations such as insertion, deletion, searching, and retrieval of data. So common types of data structures are arrays, linked lists, stacks, queues, trees, graphs, etc. So we can take an example. Let's say I want to create a space invader game, okay, and the enemy has to move from top left of the screen to top right of the screen, and from second row top right to top left, and goes like this in this direction. So we can use it by let's say we can create a 2D array. Okay, so the enemy is placed on 0 0 index on top left, then it will go to 0 1, then 0 2, then 0 3. Okay, when it is on the top right of 0 3, then it will go from 0 3 to 1 3, then 1 1 2, 1 1, 1 0. Okay, like that we can move the enemy in space invader game. So we can use data structures for that. So next is what are linear and non-linear data structures. So linear data structures are characterized by sequential arrangement of elements, where each element has a unique predecessor and a successor, except for the first and the last elements. So examples of linear data structures are arrays, linked lists, stacks, queues, etc. So non-linear data structures are characterized by hierarchical or interconnected arrangement of elements, where each element may have multiple predecessors and multiple successors. So we can take example of linear and non-linear data structures as well. So let's say that we want to create a chess game, okay, and we want to create a board for the chess game where we can place our chess pieces. So I could use a 2D array to create a board for the chess game, and which uses a linear data structure. Okay, now coming to the non-linear data structure. Suppose I am creating an RPG game and I want to create a map for the RPG game, and in that map there are different locations or different places. So I could denote each different location using a node, and I could connect all of those locations using a graph. So location A can be connected to location B can be connected to location C to location D, and D to A, and A to C and A to D simultaneously as well. So I can use a graph data structure for nonlinear type. So that's all. Thank you so much.